so I'm going to be talking about IPv6 and sort of the state of where we are and some of the issues that I'm seeing. One of the pieces of my job is I go out and I do talks, but I also talk to various folks and collect war stories and experiences and then cleanse them of the names of the guilty parties where appropriate and share them around. So I'm actually not going to be talking for the full 90 minutes. What I'm going to do is I'm going to try and give enough time at the end to actually give you guys a chance to either share or ask questions, make it a little more interactive. How many of you are actually currently running IPv6 on your backbones or in your enterprise? Excellent. And if you're not running it, how many of you are in the midst of doing your planning for the rollout and testing? Okay, good. That I think pretty much covers everybody, which is a sign of progress. For those of us who've been trying to roll out v6 for a while, it's been a very long, painful road. So, as you can see, it's the, are we there yet question. So, where really are we? Unfortunately, we're in a time of transition or change, which is a polite way of saying that it's not gelled and it's going to be a very long couple of years before we're really at the point where not just our core routers and our switches are actually running v6, but we are actually using it all the way to the desktops, and the majority of applications, the majority of content are actually available via v6. So some of the things I'm going to be talking about is, how far and how widely are we deployed? A little bit of the stuff relating to Slack and DHCP, sort of cultural things that are causing some issues and I think impeding rollout. There are also things with issues about identifying who your users are in v6 versus v4. There's a lot of stuff that I describe as interface magic. IPv6, if you start looking at if configs, is quite a culture shock when you first start doing it on end hosts. And there's also a lot of things that really are layers 8 and 9 issues. There are things that have groups that weren't playing together before who may have different roles or need to cooperate now. And I've seen a lot of shifts with companies where they're trying to figure this out and discovering that a lot of their processes needed to be at least reviewed, if not changed. There are obviously a lot of things with applications. As I said, routers and switches have been pretty mature for a while. There are some issues, but for the most part, large iron is really not the issue. It's both ends of the equation, the apps that users use and where the user types that are the biggest issues. There are some other somewhat policy-based things. How we use PTR records was rather unfortunate in v4, and we seem bound and determined to carry that forward into v6. There will be some issues. There are some things relating to the way things work with ICMP in the broadcast domain in v6 that are improvements, but are surprises. And as we all know, once something is enshrined in a security checklist, whether or not it is correct or useful is no longer relevant. It is now in the security checklist and will be in your audits. And there's some things that we need to sort of correct before they get too far out of hand. I'll talk a little bit about IPsec as well. And then I'll be talking about the IETF and what fun they are having and what that means for those of us who are actually building networks. So the goal of the IETF and the stated fact, as far as they were concerned, was that by 2012 we would be fully moved from v4 to v6. And this was the cute little graph that projected what adoption was going to be like. And as you can see, by last year, v4 had been completely replaced by v6. Yeah, it's a nice story. This is much more accurate reflection of how much useful traffic on the internet is actually going v6. It's not quite as grim, but we're still in a couple percent range, other than in certain countries. It is growing. It's one of those, World IPv6 launch last summer doubled the v6 traffic on the internet. It went from fractions of a percent to 1.5%, so it doubled. There are some bright spots. Certain countries have really pushed it out. Much like with cellular versus landline telephones, if you didn't have a lot of embedded infrastructure that you were trying to amortize out and recover your CapEx, which phone companies love to do, and you're starting brand new, you can sort of leap several generations in technology and not have to deal with legacy stuff. And we're seeing that to some degree in large internet rollouts where either they were replacing completely anyway or they didn't have as much and they were doing a major government push for expansion. Romania actually has a significant fraction of their traffic actually being used. France also, because of free, everybody got a dual stack box and it was way cheaper than most of the other providers, so they got huge deployment very early. These numbers are not completely reflective. If you look at certain types of busy content, you look at folks that are V6 reachable, Google, Netflix, YouTube as part of Google, we're actually seeing significant chunks of traffic being used. One of the other places where we're seeing a lot of adoption is in essentially greenfield. And so the mobile providers, because they couldn't get enough V4 space, many of them were shrewd enough, including AT&T, Verizon, to say, we're just going to use V6, and we're going to actually use carrier-grade NAT or NAT 6.4 as a transition for the V4 part of it. But what we're going to do is we're going to talk to all the content providers that our users use more frequently and convince them to be V6 reachable, because that means that we're not overloading our CGNs. And that was their bet, that they could get enough traffic shifted that enough of their users would be using V6 native that they would actually be able to have their CGNs take the load. And the bet has mostly worked. And this 30% number is actually a little bit behind. AT&T for their WiMAX is, I think, 25%. But we're talking significant fractions of their traffic actually is using native V6. And things like France with free at night for things like movie streaming, since several of the things, I think Hulu is also available V6, you're actually seeing 40% of their nighttime traffic, which, you know, every different type of network has a different traffic pattern, but these days an awful lot of people are getting their movies and all of their stuff. Even their cable is actually cable for internet, and then they get all of their other stuff over that internet connection. Switzerland, Swisscom just recently did a huge push, and they have now actually taken over as #1 in usage in the last few weeks. And that's another one of those. I think they're 12% usage. And it's one of those encouraging. All it takes is one significant provider in a country to shift, and we see major portions of traffic because there is enough useful content. Another one is, you know, when you look at the Alexa 1000 top websites in usage, 12% of them are actually usable V6, not just advertising in Quad A to get you to the landing part, but if you're on a V6 only network, you get almost no content and no images. There's an actual reasonable, measurable chunk of those folks who are giving usable V6 experience. So a lot of that has to do with the fact that the CDNs, Akamai and Limelight, are both now, actually Limelight has been doing it for quite a number of years, but you can get all of your content via V6 or V4, and fortunately they're not charging extra. So anybody who Akamized or did similar CDN are doing that. I'm waiting for Amazon as the major missing piece. If they do that, there's, I think, going to be another one of these sort of major sudden leaps forward. The other thing that's happening is that in Europe, because they're pushing V6 in several of these countries that are way ahead or are pushing traffic, is we're actually getting into double digits as percentage of all IX traffic at some of the big exchanges in Europe are now V6. It's no longer just the people like Hurricane Electric at the leading edge who are saying that some significant chunk of their traffic is V6. So there is some encouraging news. There are, however, as this is happening, lots of issues that we are now seeing. And this is where we get into it. So a lot of folks go, well, gee, you know, moving to V6 is really hard. You know, there are so many issues. And one of the biggest ones that is impeding many people is the fact that in V4 with DHCP, client UID is used, but the MAC address is still really the primary means by which the lease is identified with a key in the database, because the lease file is essentially a database, and it is usually how most forms of reserved or fixed address schemes or set-top box schemes work. There are some people that are using Circuit ID and Remote ID in v4, and if you're using that, congratulations, because that does work in v6. But MAC addresses are still how much of the internet is identified. Unfortunately, the IETF felt that MAC addresses were fundamentally flawed technically and therefore were evil, and they were going to completely wipe them from v6. And they had some legitimate points. You know, we get the apocryphal story of I bought 10 Taiwanese NIC cards and they all had the same MAC address. You know, so MAC addresses are not guaranteed to be unique, even though they're supposed to be. And of course, virtual MAC addresses on virtual machines. There are broken instances and spin-up software that wind up spinning up 10 virtual machines with the same MAC address. And of course, you can alter it in software even if it starts out unique. And a big problem also was that if you have a multi-interface machine, which these days all of our laptops are multiple interface, and most of our smartphones and even some of our tablets are actually multiple network interface. And if you use the MAC address, the first DHCP connection before it gets the address, and after that everyone is told you already have an address. What the IETF ignored was the fact that while, yes, all those things are technically correct, they are broken, they are undesirable, the vast majority of the internet got on using MAC addresses, and the internet is mostly still functioning by some definition of functioning, and it's how everybody does it. And as much as you can say it's broken, going to the entire world and saying your network is broken and you are stupid and you need to spend billions of dollars because we are smarter than you is not usually the start of a constructive conversation. So they came up with the DUID, the DHCP Unique Identifier, to replace the MAC address completely. And there are some things that it really does well. One of them is that there is a per host identity. Whether you're a server or you're a client, you have a unique DUID that is one per host. The way that you identify network interfaces is you have an identity association, which is a collection of addresses that belong to that particular NIC. And the pairing of DUID and IA guarantees that every network interface can be uniquely identified, therefore you can DHCP for all of them. And that's definitely an improvement. So we've now fixed one of the three fundamental flaws. But there's some problems. One of them, obviously, is anybody who's doing filtering with MAC addresses, it all breaks. Or the compromise I see quite frequently is, since v4 is still around, you do all of the authentication, all the walled garden, and everything else with v4, and it's a layer 2, and then you unlock the port or do whatever you're doing, and some of that stuff then lets you use v6 even though you've not actually correlated them. Most of us would like to know that a particular user's machine has this collection of v4 and v6 addresses at the same time. That also is currently impossible with a lease if you don't have that information. And the last one is sort of interesting. The way that DUID works is the first time that you as a server come up to serve DHCP leases, or as a client to ask for it, you check in persistent storage to see if you have a DUID. If you don't, you create it. Once you've created that once, you write that into persistent storage, which is a cute little name for usually your hard disk. And it's in the registry on Windows, and it's in usually the leases file on Macs and Linux variants. And then forever thereafter, you look in that file for it, which is fine until you do something like you ghost an image for 10 laptops in your IT department and you forget to wipe the registry of the leases file. Or you create a virtual machine template and forget that you put a DUID in. And now when you spin up those 10 virtual machines, you have 10 things that have the same DUID. So we have failed to fix the it's unique problem. And by definition, since we're writing in persistent storage, it has to be changed by software. Not only can be, but must be. So they have effectively broken all of our provisioning systems to solve one of the fatal flaws and leaving the others broken. There are some things happening. There's a draft which, at this point, I believe it did make the RFCs. It was in the ISG last I checked about 3 or 4 weeks ago, where you can put the MAC address into a relay packet from a DHCP relay. This does not help if your DHCP server is on the same broadcast domain as your clients, but it does help for everything else, and it was already there before, so at least a lot of the software in theory will be able to process it. The issue, of course, is that this means that all of the folks that you buy your relay code from, Cisco, Juniper, whoever, will have to update their code to support this, and the several major flavors of DHCP, most of which are ISC or Windows-based, servers will have to be modified to alter this, and then after that, and we figure out where in the leases it's going, then we'll have to write our software to do correlations of it because it's no longer the key. The best we can hope for is that it at least is in the lease data. And as I said, if you're doing circuit ID or remote ID, you can actually do that. That's already in the relay packets, and that's already available, and that's already supported on DHCP-v6 servers. So one of the other things out there, of course, also is the whole route advertisement messages and RAs versus DHCP. And this was one of those deeply held religious jihads of the IETF, with both sides being bound to determine there where everything should be in RAs, and we should do stateless autoconfig everywhere, and DHCP was stupid before and it's still stupid and no one should use it. And the other side of that's really lovely, except we have all of this gear like phones and printers and everything else in the world that has all this vendor option because you wouldn't give us another way of doing it other than DHCP. And gee, we want default route. And so we've had a whole series of religious wars. And so in v4, obviously, you could statically route things. That was one of your choices. Or you simply said, you will DHCP. That was how you configured. It was one of the two choices. That meant that as soon as you came up, you just you did your DHCP discover, and you went through the whole DORA process and got your leases. And one of the things you got was a default route. Now, the IETF more or less correctly did point out that if the router people who change the routing infrastructure and change what are the useful default gateways are not the people who maintain the DHCP servers and or don't talk to them, or somehow that process is missed, you will have clients who will be handed a default route via DHCP that won't accurately reflect how the network's built at the moment. And that therefore, that's their argument for using RAs, is that obviously the guys that do the routers know when those default routes change, and therefore that's the correct place to tell all of the clients where the default routes are. And there is some validity to that. V6 is a little more complicated because of all of these little bits in the RFCs. You can still statically route if you so choose. It's not my recommendation for most things. There are certain instances like server farms where it may be more appropriate, but it certainly, it's an impediment to doing rapid deployment of large amounts of servers or hosts. You obviously can't just do DHCP because you can't get a default route. And as a matter of fact, because of the way it's written, technically the intent is, it's somewhat ambiguous in the wording, and you could argue it's not the case, but the intent specifically stated by the IETF is that you should not DHCP until you have received an RA message that has certain bits, O and M bits set, that tell you you should DHCP. So if you have a client that comes up and just starts doing a DHCP solicit, which is the DHCP discover equivalent, and you've never received an RA, technically you're violating the RFCs, or at least the intent. There are some arguments in the wireless and low power about that, but in theory, you're going to need to get an RA message first. So what happens is you come up, you configure link local, which gives you a usable layer 3 address, at least on your broadcast domain, and then you send out the router solicitation messages saying, hey, who are the routers on this network? Send me your RA messages and tell me what I should do. What is this network's policy? Should I do Slack? Should I not? What prefixes do I have? Should I do DHCP? And it does make sense that the folks who own the routers are likely to do RA changes. But suddenly they have to cooperate with the DHCP people. And here we get into one of those layer 9. In a small company, you usually have a group that does everything, you know, and it may be called IT, it may be called something else. But in many places, DNS and DHCP are done by one group. Routers are done by another group. Security is done by another group. And they may all have their own little ways of doing things and their own sort of entry points for gaining service. And in the old days, if that happened and the router guy said, here's the default route, this is what you should use, and the DHCP people configured that, the DHCP people didn't need to talk to the router people again until something changed in the network. In this case, the router guys can actually break things because they can change bits so that clients don't DHCP at all, which may not be what the DHCP guys want, and it may not be what their users want. So, another bit of fun. It's called Happy Eyeballs. The story goes like this. Originally, of course, IPv6 was shinier and newer and more special than v4 and should always be used if it was available. And so all of the network stacks said, I will, if I have a v6 stack enabled, always do a quad A lookup whenever I am getting a DNS label and turning it into an address. And if I get a quad A record back, I will attempt to connect to that. Only if I fail to connect after some period of time, which, as we discovered in some testing with folks like Yahoo, could be up to 2 minutes. Only then would it actually do an A record lookup and then get to the v4. And the problem at the time was there were two sets of problems. There were people who didn't have useful v6 connectivity, but their local network advertised that they should configure v6, which is now on by default in Windows. And so they would think that they had v6, except that they had no useful route to the actual existing v6 internet. And there were other people that mistakenly configured v6 and shouldn't have because the OS had bugs. What it meant was that if you put up a quad A record on your website, some reasonable chunk of the user population would actually have a very suboptimal experience. You know, these days the general rule of thumb is that a user within 200 milliseconds of a page not loading might hit reload once, and if that doesn't work, they will go away and you've lost them to your web page. So if 200 milliseconds is way too long for people to wait, 2 minutes is, of course, outside the realm of reason. So they decided that we needed to do something else. And the IETF response was, well, okay, users don't really care whether it's v4 or v6. They want their content, so their eyeballs are happy. So they decided to do a draft. And since it was the IETF, and it was a draft and then an RFC, it was a long and drawn-out process. And in the meantime, there were users who were having problems, and so of course, some people in the IETF were also going, but that doubles DNS traffic, and our DNS servers will, at which point most of us who had operational experience said, DNS packets are small, DNS servers are big and beefy, who cares if we double our traffic? We've been doubling it anyway. Have you looked at how many DNS lookups your smartphone does when it comes up? If you do Facebook, Google, and something else on an iPhone, I think the last time I tested it was 72 DNS lookups when it comes out of sleep in the first 10 to 15 seconds. So, yeah, if you can't handle that, you can't handle that, you have other problems. Unfortunately, they were taking their time, as they will, and the browser guy said, well, we can fix that. We've already put stub resolvers directly into the browser because we don't trust the operating system to do lookups anyway, because they do things with v6 that we don't agree with. So we're going to completely bypass the operating system and get a raw network socket. We're going to do all of our own DNS. We're going to do all of our own connection building. And of course, all of the different browser people did their own, and all of the OSs did their own. Because the nice thing about standards is there's so many to choose from. So Jeff Houston, who's an interesting character at APNIC, decided to do some research. And so he went off and he found the major flavors of browsers on the major flavors of operating systems, and he decided to see what would happen as he did various things with breaking his network and how it would work. And shockingly enough, he discovered that they all did things very differently, and they all solved some problems much better than others, and all solved some problems much worse than others. And user experience varied widely depending on what combination of OS and browser you used. He also discovered that early on, this was I think about a year and a half ago that he first did this, that version of OS X had some fundamental problems because they had been doing a really good job of breaking v6 at the time. And this was suboptimal, hence hampering eyeballs. Windows actually tried to do the right thing. What they decided was it's silly to have every application in the world doing random stuff because it makes support a nightmare. Let's just come up with the same response and we'll put it into the network shim layer, and everything, including our operating system and all of the apps, will all do the same thing. Unfortunately, one of their working assumptions of that was that everybody on Windows uses Windows Explorer as their browser of choice. And the vast majority of people, at least some of the time, will use Chrome or will use Firefox even on a Windows platform, at which point they have their own stuff resolvers in the browsers and it ignores the operating system and we're back again. So, one of the other fun things, there's this bad old joke that I love about these two guys sitting out on a porch just debating what is the greatest invention of humankind. And they're going back and forth, and one of them finally says, the thermos is the greatest invention known to man. And the other guy's very puzzled. He says, what do you mean? He says, well, it keeps hot things hot, and it keeps cold things cold. The only thing I just don't understand is, how do it know? Well, we have a similar problem with IPv6. Unlike v4, where there's one address per interface, in v6, you can have multiple prefixes, all on one interface. You can have multiple addresses, privacy and globally routable, for each of those prefixes, and they all come and go. And they're kept around long enough to quiesce existing connections, but they may be existing as deprecated and not being used for new connections, but still around, and then at some point they disappear completely. And it's still a stack. So I am opening up a network connection. My first problem, of course, is choosing v4 or v6, but let's assume that I'm choosing v6. And I have two prefixes, one ULA, one GUA. I have privacy addresses on, so I have both my EUI64 based and my randomly privacy based versions of all of those. I have link local, and how do I choose? Well, of course, the IETF had some interesting ideas. They said, that's a complicated question for which we can have a complicated answer. And they started with RFC 3484, and after some input on that, they then updated recently 6724. And the basic idea is that if I look at who I'm sending the packet to, that should give me some very strong clues about what I should use as my address to send from. Because if I am sending to an address that is a prefix in which I'm configured, I'm in the same address chunk as it, it's probably not a bad assumption that it's the same enterprise, company, organization, security zone, whatever, and that the best address that I should use should be the one that tells the other guy, hi, I'm in the same address pool you are. If I'm sending to link local, I really probably shouldn't use my global unicast address. I should probably use my link local. And there are some other considerations, with different prefix lanes, like, if I have the same prefix but two different lanes because I'm configured in two different areas. And some other things you should consider, and there's some things like scope and what types of addresses. And you shouldn't use deprecated addresses for new connections, only for existing ones. And that all goes through, and we're already starting to sound pretty complicated. And after all of that, you then go through that whole thing, and there's this whole decision tree of all the stuff that you need to know that needs to be in the kernel, because it's the one constructing the package that spits it out the wire. And of course, it wasn't complicated enough, because somebody said, well, what if I don't like that? What if I have a security reason for overriding certain addresses? I need the option of controlling my host, because it's my host. I should be able to put whatever source address I want. And the IETF said, well, that's wonderful, that yes, you should have complete autonomous control. So not only do you have all of these complicated algorithms, you can conceivably, on a per host basis, have local overrides which have then changed it. And on Windows boxes, you may even have users who mistakenly did interesting things because they saw something on Google and changed something and it doesn't match the others. So You have users, because we all have users, because that's why we have networks, sadly enough. And they call us up when things don't work, and they expect us to fix them. We, of course, naively expect them to be able to give us enough useful information that hopefully we can figure out what the problem is and then hopefully fix it. Okay, so think back to the last several minutes of conversation. You have multiple addresses that come and go. What if they get pissed off and go and decide to have breakfast and come back and then call support? And your support person says, tell me all the addresses on your interface, and you can somehow walk them through. That might not be the addresses they had when they had the problem. And even if you get all the addresses, you have to get the user to get them through. You don't know for sure exactly what sequence of algorithms or necessarily what they were sending to, because as we'll also know, even though we'd like to get useful information, trying to actually get what was the host you were trying to reach at the time is occasionally a difficult question for some users. And then, of course, our frontline support folks have to understand enough of this to know what's useful to ask, and then get that to second and third tier support. And if it's difficult enough to get somebody to do a ping or a trace route, can you imagine explaining to every user how to dump all of the network addresses they have and dump any local policy overrides they might have in their system and get it into your ticketing system? So even if you wrote tools where you could simply say, run this thing and it will do Java and it will dump it all into a text file and mail it off to support and get added to your ticket. If it isn't timely, it isn't useful. And you may or may not know what's there. So I think I have no answers. I'm just posing this as another one of the things we're going to be trying to figure out. And we may get to the point where we may start putting packet sniffers on local wires and having the last half hour or hour's worth of packets available, because we can't depend on our users or our NOC to get all the information we need to debug some of these problems. So that's some of the things that we know. There are a number of things that we also have not yet figured out or are just starting to figure out. So default routes are fun. When I first heard that you could actually have multiple default routes for multiple array messages, and it would prioritize them, and that if you claim that you are a v6 compliant stack, you have to correctly be able to handle multiple default routes, fall back to a less desirable one. If your more desirable one goes away, fall back the other direction. I was just excited, and it's like, finally, HSRP and VRRP can go. We don't have to run active routing protocols in every host. We don't have to run all of this virtual MAC address and virtual IP and all of this other hideousness that we've had for years, so that you don't have to run an active routing protocol on a host. That's assuming that this actually works. What we have discovered as a collective community is that not all of the OSs necessarily did default routes and multiple default routes right. At my company, we actually ran into a problem with an older version of Fedora where it would fall over, but it would never fall back. And in some cases, it wouldn't fall over. It would correctly say, I have two default routes, but it wouldn't actually use the backup when the primary went away. They have fixed that, but OSs are software, and software is bugs. So the theory is lovely. And it does also, it's another one of those interesting debug problems, because you now need to know what default routes your users got, whether the OS correctly got the priorities correct, and at the time, which routers were and weren't available. So once again, you're into, a lot of this is very time and context sensitive. This is just sort of a weird collection of random stuff that I have found is just sort of the range of how much fun we're going to have. One of them was, we had a customer who, their security people had decided that a stateful firewall was the correct thing to protect their recursive DNS server, which of course means that you've taken a stateless UDP-based protocol and turned it into a stateful, congestible, more fragile problem. And they knew that was wrong, but they were fighting with their security people. And in the meantime, they were discovering that it was indeed less fragile, because what happened was they were suddenly getting this flood of Quad A and IP6.ARPA requests, hundreds a second, which was okay for their server, but that many requests going through filled the state table, so legitimate DNS lookups for their users were failing. And so they were going off of, well, we have v6 specifically disabled everywhere. We've gone out, we've actually turned it off, and we're puzzled. And so they had come to us because I work in the IPv6 group at my company, and they said, well, what's going wrong? And so we finally figured out, well, let's figure out what the hosts are. And of course, it was a little difficult because they, in theory, didn't have v6 on, but they discovered they did in some places. What was happening was AIX had a bug that if you disabled v6, whenever it booted, it sent this flood of v6-related DNS queries. And this was apparently some kind of service or something where they would reboot 4 or 5 of these machines at a time. And every time they did this, all DNS resolution through this stateful firewall went. And of course, the solution should have been eliminate the stateless firewall, but at least what they wound up doing was they actually put in packet filters. They enabled v6 so they could filter out, and they started doing some stuff with DNS filtering, and they figured out it was ugly. But it's another one of those little unexpected. So you disable v6. Related is that Microsoft has now said, with all their current operating systems, they no longer test with v6 disabled. You're running dual stack or v6 only, and those are supported configurations. And actually, I'm not totally sure that v6 only is supported. But if you specifically go into the registry and disable v6, Microsoft won't support you anymore because they aren't testing that anymore and they don't know what will break. And there are a lot of these weird dependencies. Another one of those fun tests, when you're doing your IPv6 implementation testing, one of the things I recommend is after you've gone through and you've built an environment that mimics your production environment that you're trying to convert, make it v6 only and completely disable v4. Almost guaranteed you will discover some hidden dependency that you didn't know about that actually still tries to sneak through v4. Another interesting one and kind of scary, the Lou Bonica draft. Ron Bonica decided to do some testing. There are 3 bits in your RA prefix message that essentially set network policy. The A bit, which is your auto-config, if it's 1, it says that when you get a prefix, you should auto-configure your own address, i.e. use Slack. There are the M and O bits, M for managed address, meaning get your address from a DHCP v6 server, and O, other configs, get all of the other stuff that isn't your address from your server. Because in v6, you can actually say auto-config for your address and use DHCP v6 for all of the other stuff like DNS servers and NTP servers and all this other crap that boxes need, but you don't need to get your address from it. Because, for lack of a better place, we set network policy based on addresses much of the time. The address that you get and how you configure your addresses is both your network and your security policy. So it's very important to know what they are and to know what the behaviors are. Ron understood that, and so he said, let's set up a greenfield. The network hasn't come up yet at all, and we will do a Linux, a Windows, and a Mac operating system current, and we will set up all the various combinations of A, M, and O bits with no previous configuration on any of the hosts and see what they do. Then we will actually change the network policy by changing the A, M, and O bits in a network where clients have already either auto-configured or gotten leases or both, and see how they change. And what he discovered was the 3 major operating systems had wildly variant Like one of them would drop DHCP leases immediately, the other would keep the lease until it expired and then would move on, which with one-day leases means that some chunk of your network acts completely differently with different addresses than others. Ron, being Ron, then said, well, okay, so the OS vendors obviously some of them must have done it wrong and failed to follow the RFCs. So we went back to all of the relevant RFCs mandating how A, M, and O bits are configured and what the expected behavior is. What he discovered was that the verbiage in some of the core RFCs that have been around for a decade or longer but have not been reviewed carefully in operational environments were sufficiently ambiguous that you could make the argument that every single one of those vendors had not violated the RFCs. They were protocol conformant, they were simply not at all interoperable or consistent. So there are two useful things. One of them is Appendix A is very useful to all of us because we can look at it and know when we're trying to change our network what families of OSs will have which behavior, so we at least know and can plan for the fact that we might have a day's difference between the Linux boxes and the Mac or the Windows boxes and how they behave. The longer task and the scarier task is we now know that these things are ambiguous, but some of them, like the DHCP draft for 3315, the DHC working group in the IETF has said for a couple of years now, we really know that it's not clean. We really need to do a BIS. We're not sure if we don't really want to add new functionality, which would be a new RFC number. We actually need to correct significant errata and ambiguities in 3315, and they still are not doing it. And even if they started, unfortunately, BISs are usually a 3 to 4 year process in the IETF from the time that you start doing the drafts. Because as soon as you touch it, all the people that were bent because they didn't get the way they wanted things in the RFC last time around are still at the IETF, and they haven't forgotten. And you basically get to re-pick every wound that you picked at last time around. And however long it took you to get the draft out last time is usually about how long it will take you to get a BIS out. And of course, what do the OS vendors do? Because until they have some clear indication, they're all hoping that they're the one that is closest to correct and that the other guys are going to have to code. So none of them are going to do anything. And I, working for a vendor, I also know if I go and say the standards are flawed and we need to change our product, the first question is going to be, what customer isn't buying our gear because of this problem? And what other customer will cause a support nightmare when we change this behavior? And by the way, we already have the roadmap set, so you won't get engineering resources unless it's a security bug for the next 6 to 9 months. And so we're going to be living with it for a while. One of the other areas that is going to be a long trail item, apps. They are the worst things we have now. They will always be the worst things we have. And there are a lot of changes. It's hard enough to, even now, I am more likely to see botnet and malware code that uses DNS labels rather than hard-coded IP addresses in code than stuff from companies who are paying real programmers real money to write stuff that they depend on for their business. I am more likely to see malware and distributed denial of service attack stuff that makes clever use of the networking stack and correct use of addresses than I am database to backend server or web farm software that actually understands how to correctly open a socket and set various bits. So that's the existing state of the art as it were in v4. And we've now just changed all the rules. And mistakes are potentially more painful. There was a great presentation at this last write a few weeks ago about making apps IPv6 ready. And basically, Bert Hubert went through his own code and discovered a bunch of things that he was not doing terribly cleverly. But it's probably the best breakdown since Dan York's book with O'Reilly, which is now 3 or 4 years old, and even Dan will admit is sort of due for an update. But at least we have something to point your coders at to have them start trying to fix things. And in the same way that DNSSEC forced us to clean our code and our configs for things that were really broken in regular DNS, but we'd gotten away without fixing for years, DNSSEC didn't allow us to be sloppy. V6 is going to force us to probably clean up V4 code as well so that it works correctly in dual stack. And so that's certainly one of the things you can point your coders to as a reference. And of course there will be more, and I'm hoping, maybe some of you have some, well, I call them amusing stories because I have a very bitter and twisted sense of humor, but share what you've been doing. And of course, the next bit of fun, CPEs, because consumer gear is always special, as in rides the short bus, wears a helmet to school special, but, and V6 of course has a number of changes. We're not seeing it yet. In V4 you got one address, and then you natted everything to usually 192.168.1 or 192.168.0, and that's how 99% of the world works. Well, at least they are saying, gee, we should give them a real V6 subnet in V6, and that's less controversial than it used to be. There are still providers that are saying a home should get a /64, which is really one single subnet, because you can't subdivide below that. It breaks slack. And it breaks a number of bad stacks that assume the rightmost 64 bits was the host ID. And if anything's going to have bad code and expedient assumptions, it will be all of the gear in a house. So prefix delegation, where you actually can allow a whole prefix, a 56 or a 48 or whatever, to be handed to the main router connected to your cable modem or your DSL modem, and then it subdivides, is happening, but that means that you have to be able to do prefix delegation up. And fortunately, most of the BRAS and CSLAM and all of the other provider gear is now getting there, and DOCSIS 3 has made this a lot easier because a lot of that stuff is built in there. But you still need things within the home that also ask for subnets if you're doing hierarchical, which is the grand scheme eventually. And of course, the reason that CPE gear is fun is much like the old days of consumer PC stuff. I can shave 25 cents a board off of my wholesale cost, and all I do is make your life a total living hell and make this a support nightmare. And I'm cheaper than the next guy on the internet, and I win. And CPE gear is all built into the assumption that $2.99 is better than $3 to the consumer, and that $2.75 is a huge win, and they don't ask how you saved a quarter. They save a quarter by hiring interns to write code, by using public domain open source code that has been deprecated for the last 10 years. All sorts of interesting little tricks. Quick little sidelight. Open resolvers and the Open Resolver Project.org. One of the problems with distributed denial of service and DNS amplification is that if you have an open resolver, it is just a large bore shotgun waiting to be used by botnets to hammer the victim of your choice. And they've gotten it down somewhat. It was at 31 million open resolvers a month and a half ago, and I think it's down into the 24, 25 million. So progress, but that's 25 million resolvers. Well, we can all sit there and we can say, all of the DNS servers should have ACLs on them, and all providers should be doing various filtering. And most of them already do. The problem is that they discovered that many CPEs will answer DNS recursive query requests on their WAN side with no filtering, which means that every home router is another open resolver. And we all know, as soon as you say you need to replace 30 million users' gear in their house, and they'll have to spend money, or you'll have to send a service truck out, and they won't understand what you're fixing, that you're charging them money or making them waste a half day from work to wait for the repair guy, you're 4 years easy to any kind of significant rollout. And there are literally millions of these things with old crusty code. And there are people who just do broken stuff. I have an old Apple Airport Express that I just moved recently, and much of my stuff was in boxes, but I have my little thing that I travel with in the hotel so I can get wireless and share my connection that they want to charge me per machine for. And so I said, well, you know, I just got Comcast, and Comcast has V6, and I have my shiny new DOCSIS 3 cable modem, and I'll just stick my Airport Express on it because it does V6. Sort of. It sort of does prefix delegation, but it wound up doing it in a way that was broken enough that it confused Comcast, and I wound up going to their 6-to-4 service for my V6, even though they had native V6 available and correct prefix delegation. This is an older model, but the most current code from a real vendor. And I actually have updated it, so I'm actually ahead of your average consumer who has a 6 or 8-year-old piece of gear. I had to replace it with a real router before prefix delegation worked, which was fine because, you know, once I found the right box that they had carefully hidden it in, because movers are interesting people too, it worked. There are tests, and RIPE has a whole document, 554, where they've actually done CPE tests. So if you are a provider and you're trying to come up with a, here's what we prefer you use, because this will actually work with V6, and we're trying to promote V6, there are people out there. There are also organizations. You know, obviously Cable Lab is doing a lot of testing of a number of different things as a consortium for all of their cable provider members. And they've done a lot to push this out. And large providers like Free and Comcast and others, yes, they're doing it because of bottom line concerns. I mean, Comcast originally did all of this because they were using their third round of Network 10 for different customer clouds, and they were getting tired of having to have the NOCs have 3 different connections to the which Network 10 am I connecting to for this customer. And so they actually went to V6 simply because it was killing their NOC. But yes, those folks are doing testing. The other is University of New Hampshire Interoperability Lab. It's a fee service. It's not cheap, but they have dozens and dozens of very smart grad students as slave labor and extensive testing facilities, and they are doing very good stuff. They are actually what the U.S. government is mandating for compliance with the USGV6 standard, which is the useful definition by NIST of what does it mean when you say as a vendor, I am IPv6 ready or capable, that's actually useful for the government buying gear that they know it will actually work, as opposed to, I've seen definitions like, I'm IPv6 ready means you can configure a v6 address on the interface. It won't actually use it, and it won't do Slack, and it won't do a DHCP, but you can hand configure an address. So, UNH actually has testing wherein they sort of blow large holes through specious little arguments like that and give actual reports. And of course, NAT, you know, I have a whole series of what I call beer bets. I bet a beer that. And one of the beer bets I had 2 or 3 years ago was, you know, because everyone's going V6, so we have so much address space, we'll never need to NAT. And I immediately went up and said, I bet a beer that someone will write NAT 6.6. And everyone was like, that's hideous. Why would you need NAT 6.6? NAT 6.4, yes, it's broken. And I said, it's very simple. PCI compliance and various other security checklists have this thing that you go through and they get audited. And it's getting better that they still have a NAT as a requirement for V4. Now, the reality is, of course, is that the stateful firewall piece of it is actually what they're mandating, where one public address hides multiple private addresses behind. And it's not even that it's private, it's just there are multiple addresses behind that are not individually addressable from the outside, so it is one more impediment to attacking individual machines, which is correct. But it is a stateful firewall part of it, which you could recreate with a stateful firewall. It's not NAT inherently that does that. But the security world, in many cases, has erroneously conflated those two. Therefore, if you're doing PCI compliance for credit card processing, you can use a stateful firewall and not do NAT. But you have to go through several extra steps, and some auditors will still ping you. So if you don't want to argue with these people and throw engineering time at it, you just throw up your hands and go, okay, NAT. NAT 6.6. It will happen. But at least for houses, we no longer need to do that. We can actually have useful public routable addresses all through the house. And our providers can actually do some debugging. And so, okay, fine. So we won't map, we'll use address space. And then we get into the conversation, well, 64 really isn't enough because it's one subnet. We are now getting to the stage of, I'm a geek, I have more than most, but it's not unusual, even at relatively non-geek, to have all of your home theater shit on V6 or on V4. My AV receiver and my TV want to do internet updates. Thanks. Yeah, I love not watching TV for half an hour because I'm getting a software upload. But it's happening. And most of us have a home office. And if we have kids who, after they finish their homework, are going to want to play World of Warcraft or Halo or whatever else, or get on Xbox. And you want to be able to segregate that traffic out so that the video conference that you're actually getting paid to do from your house is not torched by the Xbox session that your kid is doing. So we're already moving to a point where having a hierarchical network in a house actually makes sense. And Chris Grundeman's doing a talk on his HomeNet, HipNet stuff, on some suggestions on how we can make that simpler. But there is very little argument that we need more than a 64. There are debates as to how big that should be. There are, of course, Owen DeLong and the HEs of the world who just say all subnets are /64s, including point-to-point links. All home or all internet connections are 48 or shorter. No one should give out longer than 48 to anyone, including a house. Okay, cool. I like the idea of having 64,000 subnets in my house. Sounds fun. Practically speaking, most of the world, another one of my generics, would I want to support my mother remotely over the phone doing X? Do I really want to explain to my mother how to deal with 64,000 subnets? No. Do I want to explain to my mother what a subnet is? No. So there are some debates. I'm seeing 56s as fairly common. The only thing I'll say is most of them probably make sense. I would just say stick to nibble boundaries. So 48, 52, 56, 60. I would recommend against a 64. I think that's bare minimum should be a 60 and probably a 56 because as an industry we're very bad at predicting what will happen in the future or what future usage is, and we wind up doing horrible contortions to get ourselves out of them. Like classical routing to CIDR was one of those spectacularly fun periods in my life. So call their bluff. They're saying we can't possibly ever run out of V6 space. It's just there's so many gobs that we will never. Okay, fine. So start allocating everything in nibbles. It's certainly a lot easier because it means that each one of those little hex characters in the address that you type out is a nibble, so you're not dividing in the middle of a letter. Another one of my beer bets is that really, really large, even really, really large number that we can't quite quantify in our mind is not infinite. Infinite is still way bigger than really, really large. And I have a beer bet that right now, blowing off this English paper and playing Assassin's Creed is somebody who will have an idea for something that will not use a real data structure, and he will decide that sucking up IPv6 subnets somehow is easier. And whatever it is will actually be something that lots of consumers will really, really want to use. And every time you run it, it will suck huge amounts of subnet, and we will suddenly get to a point where we are exhausting what was inexhaustible. So, someday, lots of people will be buying me beer. There is the routing problem with prefix delegation, and to some degree, look at HipNet. There are a number of proposals. The IETF, of course, is now recommending that the way to get around all of this and do topology discovery and efficient routing within the home and all the rest is to simply use ISIS for all the routers in the house. And another of how many of you would be willing to support my mother running ISIS in the house? Yeah. But they are thinking about it. Yeah. Oh, but she could use OSPF if she thinks ISIS is too complicated. Okay then. So you obviously don't really deal with actual people in your job. One of the other bits of fun, PTRs. Well, a little bit of history. Way back in the dark ages, I worked at Unet, And it was one of the two large FTP archives that was, actually there were several. DEC had one as well, and Washington University St. Louis had one. And we got to the stage where our founder, Rick Adams, was getting very tired of getting emails from people who didn't understand what their password was for anonymous FTP. And being Rick, he decided he simply wanted an automated solution. So what he did was he said, okay, if you try and connect to our FTP server and there is no PTR record matching the IP address that you come in with, we'll simply say your PTR records are broken, go away, and either they will go away or it was an honest mistake and we'll fix it. And the email traffic to this particular alias went down and Rick declared victory. And then at some point we got to this point where I believe Qmail was the one that was the most aberrant. We were getting people who had broken MTAs that were connected to us and doing stupid stuff. And so he said, screw this. And so he had Eric Allman put in a hook to SendMail to allow you to do a PTR lookup. And if you didn't have forward and reverse matching, we said, go away. We don't want to talk to you. And other people started using it, and it started getting used for VPN concentrators. And New York Times website actually cares if you have a PTR record, and you won't get certain content if your provider didn't do that right. And so what's happened is it is so ubiquitous now that all of us simply, whenever we get V4 space, we simply pre-configure the entire zone because we don't know what will break and we just don't want to deal with the users. Mea culpa. We never should have done it in the first place. It was a moment of laziness that we have been paying for ever since in maintenance, and it was a bad idea. And how do we do it? Well, of course, we could do it by hand, but most of us were Unix geeks, and so we would either write scripts or then eventually, of course, things like find started with $generate. These days, there are even commercial products, including my companies, that will actually pre-generate everything in the world that you want with very fancy options. Okay, so that's really great. So I get a /22 and I pre-configure all of it in my zone and I'm done. Well, a little bit of V6 math. A single subnet in V6 is a 64, which is 18 quintillion IP addresses, which is 4 billion times 4 billion, which is a lot. The DNS label itself is 34 labels long because it's the 32 nibbles plus IP6 plus ARPA. So we're talking, 80 to 100 bytes per individual record. So if you take 18 quintillion and add 2 more zeros to it, which is a number I don't even know, who has a disk that will actually hold a file that big? And we won't even discuss what you would get charged for RAM that might hold that zone file. So what do? Well, we could just all admit that PTRs were a momentary lapse of laziness and stupidity and write them off. And that's certainly what I would advocate, but I also know that that will never happen because users will whine. We, of course, could try and pre-populate if we could somehow defy the current laws of physics. More practically speaking, statically configure all of your large service machines and all of your routers and all of your network gear interfaces because things like traceroute and MTA connections and all of those things will need it anyway, and there aren't that many of them, and usually if you automate your provisioning process, you can automate this. That's certainly the bare minimum I think that anybody can credibly do. If you're doing Slack, you're kind of screwed, but most of the time with Slack, it's usually smaller and embedded devices, it's usually not users, is where I'm seeing Slack, and it's certainly where I recommend using Slack because it's much lower overhead to write a stack to do that than to do a DHCP client. But most actual users who are doing things with websites and VPNs and all that other crap are likely to be doing DHCP v6, at which point the server can add the records and groom them and clean them as they come in and out. And so we still haven't fixed the broadcast domain. I can have 18 quintillion addresses, but practically speaking, if I get more than 3,000 or 4,000 hosts actually spitting bits on the wires, it's not going to work anyway. So at that point, that's a finite number that can go into a zone file. The last suggestion, which people have asked for, but I'm unaware of any commercial implementation for, is you simply line the fly. Somebody says, is there a PTR record for this? And you go, yep, here it is, and you just make it up at the time. It would certainly be relatively trivial to do that. The only downside, of course, is that DNSSEC then breaks because DNSSEC was designed to not let you lie. The only way you could make that work would be similar to the way the CDN folks do that now at DNSSEC, which is you have to put your private key on the server doing the lying, and it has to actually do prime number math as it calculates that for every one of those requests, which is a marvelous self-denial of the service attack waiting to happen. Much in the same way that doing NSEC3, if you don't have to do NSEC3, is a great way to beat your own server to death for no useful reason. ICMP to v6, another big change. It's actually a major improvement. ICMP v6 is much better typed and defined so that you can give the behaviors you want and disallow what you don't want in a much more precise fashion. Getting back to those security wonks who like easy answers, and they say, we don't care about network monitoring, we don't care about any of that stuff. I'm turning off all ICMP because ICMP is a security issue. Okay, so that's a lovely thought in v4, and basically all you've done is you've made your networking staff miserable. But reasonably speaking, all of the user traffic will still work. In v6, ICMP multicast messages are used for many things, including duplicate address detection, because the DHCP server doesn't do that anymore. So if you want to make sure you don't have more than one host trying to use the same, you use duplicate address detection. You cannot ask for route advertisement messages nor receive route advertisement messages without ICMP v6, which means you get no default gateway, you get no DHCP, you get no DNS, you get none of the other stuff that we get those configurations. You can't even find a DHCP server if you wanted to. And PMTU, Path MTU discovery. In v6, intermediate boxes in the network are no longer allowed to fragment. Only the original sender of the packet may fragment. So if I send a 4K packet and somewhere along the way there's a router that can only send 2K upstream, what it does is it throws that packet on the floor and it sends back an ICMP v6 packet too big message with the note, please use 2K. And as it goes through the entire pipe, it sort of gradually shrinks down to the smallest amount that will fit through every pipe in the path. So what happens is some random box somewhere out on the internet, way away from you, throws your packet on the floor and then sends back an ICMP v6 message, which if you're filtering, you never get. So you keep shoveling out 4K packets and it keeps throwing away and eventually you time out. Obviously, you can't do pings and trace routes and various other things. So if you don't care about having hosts that have no DNS, no routing, possible duplicate addresses, and can't do anything other than essentially annoy everyone else in the subnet, and you consider that a useful internet experience, turn it all off. Congratulations. I give you about 2 minutes before your users come looking for you with pitchforks and torches. The IETF did an actually excellent job in writing an RFC that explains sort of these are the things you really can't turn off without breaking v6 completely. Here are the things that if you're doing this like mobile IPv6, you will need. If you're not doing it, turn them off. And then certain things that it's like nobody other than a research lab should play with. And it sort of breaks them out into those broad categories. So my recommendation is that you get this RFC, you print it out, you carefully paste it to a very large board, and when you get one of these, I want to turn off all ICMP v6, you take the board and you pound them on the head until they relent, and then tell them to read that RFC. And IPsec. This is one of those lovely stories. And there are two things that I always hear about IPv6. One of them, of course, is there's so many addresses we'll never run out. And I've already given my really, really large is not infinite. There's another one, IPsec is better, and IPv6 is more secure because IPsec was designed in from the beginning as part of the protocol. It wasn't glued on the side afterwards. And this starts with a once upon a time and ends with a and they lived happily ever after. The way it really works, the RFC that specifies IPsec did say must, now says should support IPsec. The US government has mandated that they still require must anyway. But that really wasn't the big problem. The problem was that they said should support IPsec, and they failed to define what support was, which meant that all of the OS vendors got to define support. And the way they defined support was We will ship software on the distribution medium for our operating system. If you can figure out how to make it run, congratulations. That's support. And unfortunately also, one of the things that the IETF failed to do, because they couldn't agree, was they couldn't agree on a public key infrastructure, a PKI. What this means is that you can't have asymmetric keys and have a way of securely sharing key material with the clients. This means that you must do symmetric keys that are pre-configured on both ends, on the VPN concentrator or termination point, and on the client. If this sounds remarkably like what you're already doing in v4, yep. So good news, bad news. Good news is, if you are doing IPsec in IPv4, and you have figured out how to provision your users and your collectors, and this all works and you have IPsec up and running, you can do exactly the same thing in v6 and it will work just the same. The bad news is that it is no better than v4. The sole exception being Microsoft with their direct access product, and the reason for that is because they, when you do your Windows AD authentication, are doing Kerberos underneath the hood. They may put their little GUI stuff on top, but it's Kerberos, which means that when you give the login and password, one of the first things you get is a ticket granting ticket, which is essentially a secure way of then exchanging other credentials. So you have to pre-configure the server side for additional services like direct access, but you don't ever have to touch a client at all. The next time they log in, they will get the new credentials securely. I mention this because this is Microsoft. Microsoft did the right thing. This should make every Linux developer in the world horrified enough to go running off and fix this. I'm hoping. And the IETF. We all love bashing the IETF because it's fun and it's easy. And they seem to deserve it so often. One of the things about the IETF is they are very ADD. They have a relatively short attention span. They want to go to the shiny new problem. And so they are continually adding things and making things more complex and elegant is usually the term they use. I use complex. And adding more and more stuff, even though the base stuff isn't there yet. This is now 3 months old, but there are literally as many drafts working right now or more in the process relating to v6 and DHCP v6 than there are RFCs. And it was something like an average of 30 pages per RFC across all the RFCs, and if you have to actually go back and read some of the obsolesced ones because of some subtle points, it's like 150 to 200 RFCs at 30 pages. So I am a vendor. I now pretend I'm a software vendor and I'm writing an IPv6 stack. Congratulations. So my system developers now get to read thousands of pages of RFCs with no relative importance of one over the other and with occasional ambiguities between them or apparent conflicts between them. And they're adding more stuff every single IETF meeting. There is yet another IPv6 transition technology added to the pile, and I mean the pile of transition technologies. There are so many that it is impeding rollout because you look and go, which of them is appropriate? And you look at all of them in horror and confusion. I find half of them confusing, and I do this for a living. So, as I mentioned, RFC 3315, which is one of the key DHC RFCs, needs a serious rewrite. We're years away from having that settled. The other thing I usually do this when I'm talking about why you're already too late in your IPv6 planning if you aren't already in your test lab, even if you're not rolling out for 2 years. Some change happens or some new feature happens in the IETF and it's put into an RFC. It would be very, very aggressive to assume that somebody might write a reference implementation within 3 months after that is finished. It would be as aggressive to say that within 3 months they might be ready at the point where some customers might be beta testing whatever this is. Another 3 months to actually get it into production, for the vendor and another 3 months for you to roll it out enterprise or network-wide, those are all stupidly aggressive. But what that just says is 12 months from the RFC finalized to it's actually deployed useful in your backbone or on your enterprise is a stupidly aggressive schedule. So if you aren't going to the IETF now and saying, I need this or I can't roll out V6, you're 1.5 to 2 years away from having a useful implementation from Cisco or Juniper or HP or whoever. And there are other bits of fun that we're just now discovering. One of the ones, there is an RFC for how to figure out your recursive servers. I'm a dual stacks host because that's what the IETF recommends as the most stable transition technology. So I do my DHCP v4, and I get an address, and I get a default route, and I get other stuff, and I get a list of DNS resolvers to use. And for this example, I'll assume it's Unix, and I rewrite my etcresolve.conf and I stick all the servers in. Now I configure link local, I bring up my v6 interface, I get an RA message that tells me I should DHCP, and I go off and I DHCP on one interface, and it gives me a bunch of DNS servers. And because I'm multi-interfaced, I do multiple DHCP v6s, only one v4, but I can do multiple v6s, and I DHCP for all the interfaces on my multi-interface host. And every time I get DNS servers. And what do? First one wins, last one wins. Keep them all. If I do I keep them in the order I got them? Do I sort them? If I sort them, in what order? RFC 6731 says your cellular interface might need to use a certain resolver because they're doing DNS magic and lying to you when you go over cellular, but if you use that same DNS resolution on your local LAN, it will break and vice versa. So I need an etcresolve.conf that the kernel can talk to for every one of my network interfaces. And I'm not aware of any operating system that deals with that. There are a number of things along those lines. MIF is multiple interface. And as you have multiple interfaces, each of which might have administrative and network policies because of security or cost for cellular or speed or any number of other things, you essentially wind up having virtual networks and virtual operating systems that have to be segmented for every network interface. And so there's a whole new working group to deal with that. PKI, of course, is another. They still can't agree on a PKI infrastructure, and it's impeding a number of things other than doing things like IPsec. DNSSEC, we're still having that problem with, we have 5011 and some automated ways in theory of pushing DS records up, but we really aren't there yet. There are a series of operational issues, and it's sort of there, but only because we've made that leap of trust and we all agreed that we had to use the root for DNS anyway. Therefore, if we sign the root and use that trust anchor, we've sort of solved it. Things like Dane, the idea of putting certificates into something, possibly DNS and DNSSEC signing it, have the same problem. We don't like the idea of certificate authorities because those are corruptible. But then we get into then who owns it. And as soon as you get into who owns it, the IETF seems to freeze. RPKI for secure route announcements is another. They haven't yet figured out how we're going to be sharing and distributing keys or who's going to start with it, how do you trust, and all the rest of it. We keep running into the same problems over and over again. So what can you guys do? You can certainly get onto the working group mailing lists. I will warn you, most of them are voluminous and painful, but you certainly can. You could come to the IETF, and I'm actually going to be doing a lightning talk, possibly this NANOG, about essentially having a support group for operators who come, because there are cultural things that if you haven't been to the IETF, you need to be prepared for, and there are ways of working that are more or less constructive than others, and we're trying to set things up so that it is not as painful as it used to be. But realistically, they don't announce the agenda until 2 weeks before. You probably only have 2 working groups you need to go to, but that means that you have 4 hours worth of work across 5 working days that you have to take off of work and travel. It's frequently overseas, 3 times a year. Most of us don't have the luxury of being sent to IETFs regularly. But you certainly can. We're trying to do some things with the IBPCOP, the best current operational practices, and the talk for that is at, I think, 4:15 today, of can we get more input to and more visibility into IETF? How would we do that? And this may sound strange coming from a vendor, but beat on vendors. Because I can't do anything. I can go and I can say, this RFC just passed, and we need to put it in because customers are going to need it. And the question I'm going to get is, what sale does this affect and how many dollars is that? So if you as customers don't say, we're not going to buy so-and-so's gear until you support these features or this V6 option or this RFC, we have no way of getting engineering resources. So please, beat screen. One of the things that I usually say is that if you want to be able to have a rollout, most of us have capital budgets that are already set. And then, of course, if we're supposed to implement V6 on top of that, we're not given any extra money. Well, one thing you can do is if you have a 2-year hardware refresh cycle, which is not uncommon, or a 3-year refresh cycle, and you say, as of today, nothing that comes in that I buy will not have V6 support or a solid committed roadmap from my vendor. As soon as you do that, you're not adding to the pile of crap that you have to transition. And over those 3 years, the vendors will finally get all of their stuff actually working. You'll test it, you'll roll it out. And at least in 3 years, just buying the hardware you've already committed to buying, you will have a V6 capable network. And the vendors will have some justification for actually implementing this stuff. So, questions, comments, stories?
Hi, Paul. Good talk. I've got a couple, comments and questions. I guess first of all, I'm happy to hear you talk about prefix delegation and how important that is in a service provider network. I'm curious, what maybe your take is from a vendor perspective or what you're seeing. The company I work for, we work with a lot of telephone companies who have a lot of end user subscribers, residential subscribers, and everybody talks about vendor-wise, hey, we're going to come out with these residential gateways, but no one talks about prefix delegation. You ask them about that, and you get the deer in the headlights look. And to me, I think that's a huge deal. That's one of the biggest benefits of V6 is the ability to delegate multiple or a single prefix to the home that can be used for multiple things. And I think from a security perspective, it makes a lot of sense. I don't want maybe my DirecTV box kicking its feet around in the same network with my home computer or whatever.
And quality of service is at least potentially there, or traffic shaping. Yeah.
Yes, absolutely. So I guess my first question is, are you seeing much on the CPE front from that perspective? I mean, I know a lot of the fiber to the home vendors, a couple of them say, yeah, we're going to build that functionality into our ONTs.
Yeah.
Well, no, they're not. I mean, I haven't seen it yet.
I'm seeing more in terms of set-top boxes being done in Europe with those capabilities than in the U.S., but set-top boxes in the U.S. are going away. Well, I'm seeing less other than Google. Most other vendors seem to be finding other ways of doing things now, but it is starting to happen. It is part of the problem, of course, is if you go to any place where they're actually selling gear, the people there don't even know what V6 is. But it's not an accurate picture because they probably are developing it or have it. It's just it didn't make the marketing literature. And when you're talking about somebody the size of a Cisco or a Belkin or a similar, until it's on a little glossy 2-page at Interop, it doesn't exist. But prefix delegation is coming. A lot of it is because of some folks, Time Warner, Comcast, and some of the other big folks in the U.S. have been pushing a long time. It has helped a lot that DSL speeds have not kept up with cable speeds, and cable is becoming more ubiquitous in more rural communities, and DOCSIS 3 is already done, so that's helping.
Right. Yes.
So I'm seeing it. It's still going to be a while, or I'm actually not seeing it, is anything above consumer. Like, the small to medium business market, an office size router, I'm not seeing prefix delegation there, and that's even more of a place where I would think you would want it first for security and traffic reasons than even in the home. But there's nobody pushing for it because businesses don't even know what it is or to ask for it or why they care. And the phone companies are hesitant because they don't see a way of charging extra for businesses. In home, they're being forced to because they need the address space because of the sheer numbers. So there's no pain point for the phone companies, so they have no motivation. The customers don't ask. And so that's one of the gaps that I'm seeing.
Okay. And to me, it just makes sense, especially for and I agree, the DOCSIS folks seem to have their act together. They do the PD, they do route insertion, everything else. I guess my next question, and my last question, from a deployment standpoint, are you seeing most, from a WAN side doing, so let's say you have a DSL network or a fiber to the home network facing a group of subscribers. Are you seeing more, stateless auto configuration towards the subscriber's WAN interface, and then the prefix delegation being done over that? So in other words, they do their, they get their link local address with, on that subnet. They see the router advertisement. They built their EUI64 or whatever. They have network connectivity, and then do a prefix delegation over that. Or are people looking at doing some type of more of a tunnel approach on the WAN side, or what's your thoughts about that?
I haven't had as much exposure as I would like. I need to corner a few more people, but what I'm seeing is they are using DHCP for the point-to-point link because it's very similar in provisioning to the old PPOE.
Yes.
And some of the others, so it sort of makes sense to them. And then they will prefix delegate to the LAN side of it, and then it becomes whether it's a 64 or it's actually I don't consider 64 a useful prefix delegation. It is, but I don't consider it useful.
Yeah.
If you're going to bother to do prefix delegation and it actually works, I feel you should give somebody a 56 or at least a 60. Yeah. But most people are phasing it. And even Comcast started out with a 64 and moved up. They seem to want to dip their toes. But that's what I'm seeing more of is DHCP up and then DHCP with prefix delegation for the LAN side.
Right. Anything less than a 64 would be pointless. I mean, if you would make that smaller prefixes within that, you're gonna break everything else.
There are enough cheap stacks that have hard coded that the rightmost 64 bits is the host that you will break it. So yes.
Okay. Thanks. Appreciate it.
Good morning, Paul. My name is Jeremy. I was just curious. I heard you comment about Amazon kind of coming up the curve. I guess have they committed to a date yet in regards to IPv6 implementation?
They are very careful about what they announce in general, and so their engineers are carefully controlled. So even though, I can hear rumors, but there's still not enough of a business push yet. Amazon has enough v4 space right now that it's not impacting their virtual machine yet. When they hit tilt, that will change. Limelight did it because their management was committed to v6, and which is why they've had it the longest. Akamai had it because they had all the government requirements for v6, and that was how much of the government sites were going to meet the last fall mandate that everyone has missed. Amazon has some government customers, but it's not the same leverage, and so they're being ignored. Amazon also does a lot of custom stuff, which is both a good and a bad thing. Limelight took so long when they did theirs, and Amazon took so long when they did theirs, because it's not commercial off the shelf. They're doing everything.
Makes sense. And we actually work with a company called IPvS. We do a lot of tier 2 and 3 DOCSIS work, and so we're seeing a bit of a push now that some of the larger guys have kind of led the way. But we're seeing a lot of issues, obviously, with the consumer gear, like you were saying. So when you're talking about larger prefix delegation, I mean, we're seeing issues with consumer devices right now, even just taking a prefix, much less anything larger than the 64. So do you see that's a trend going forward, or do you see like maybe multiple 64s?
I see usually one of two things. If it's a relatively recent code from a relatively reputable vendor, they actually do correct prefix delegation because they realize that taking 64 is prefix delegation and you should just do it. I haven't seen too many people that I'm aware of that have actually hard-coded getting 64 with prefix delegation but not being able to take a shorter prefix than a 64. And you'd actually have to do work to do that. So I'm hopeful that nobody will be that overly clever.
Thank you.
Hi there, James Ashton from Wide Open West. Just wanted to make a comment on one of your earlier slides with regard to, I guess, prefix delegation and acquiring IP space and actually dealing with Aaron. We just consolidated, gave back a bunch of various blocks that we had distributed and tried to acquire a single larger block. And had some issues with them when trying to justify handing out multiple blocks to homes. As far as like, how do you justify giving a 56 to a house? And we ended up having to take a much smaller delegation than what we actually thought we could reasonably justify, because they didn't feel that a 56 at a home was necessarily valid, which, you know, seemed kind of odd.
Aaron's address policy is, and dealing with allocations from Aaron is probably the most painful of the RIRs. You could make the argument that they are the most rigorous in going through, but I don't agree with a lot of their working assumptions either. It's interesting that even though they have sort of the embarrassment of riches in both V4 and V6, they are more difficult in dealing with, in getting those out. And even though they're supposed to be encouraging V6 adoption by having a more liberal policy, that I've heard from folks other than you that is what they say, but it does not seem to be what they allocate.
Yeah, I'm just thinking, you know, from a cable market point of view, how, you know, right now we're spending a great deal of time figuring out how we're going to deploy, because, you know, we might actually be, if we assume that we're going to be deploying multiple subnets to a home or multiple 64s to a home in some sort of a nibble range, that we might actually be short on IPv6 space already.
Yeah. Now the plus side is that everyone is doing sparse allocation. So if you get a 36, what actually happens is you get the front half of the 32 and they leave the back half of it available for you for later, so you can simply change the prefix length. So they are being accommodating in that regard. My email's on the slide if you want to go through. There are some justifications you can use with some of the trends. Smart grid, Internet of Things, the fact that there are enough decent consumer grade, anything that is gamer rated routers these days are actually doing PD correctly and doing V6 correctly. So a lot of that stuff, if you scrape enough of those arguments together, it might start to sway them. But yeah, email me. I can see if we can try and come up with some justification to change their mind, because it will be benefit to more than just you.
Hi, I'm Bill Darden. I'm on the advisory council of the American Registry for Internet Numbers, and we're always anxious to hear feedback like this. And if we have policies that don't seem to be operationalized, or policies are incorrect, there's quite a few of us here who are going to be on the agenda later in this panel, and so all of us are anxious to hear your experiences, either good or bad.
And thank you, and I'd love to talk. Some of it is also chicken and egg. I mean, part of the issue is there are very few providers that are actually pushing. An awful lot of providers started with the 64 and are gradually upping what they're handing out. And a lot of that has been slow because CPE equipment has not been there yet. So we have so many things that are lockstep and dragging this along. So as long as I think everybody's willing to, you know, it's the whole theme of this thing is we're going to be constantly changing everything, including fundamental assumptions, over the next several years as we actually roll this stuff out. And as long as everybody's sort of prepared to roll up their sleeves and deal with that, I think we can get through this.
So I'm with you, and I've heard both sides of this now. You know, on the one hand, you're saying, you know, if there's no sentiment of conservatism in IPv6 addressing policy, we will use it all someday. On the other hand, we don't want to limit, deployments, and the 56s are the things that ought to happen, and the policy says it should happen and it shouldn't, that it's an operational problem, and bring that, there are vehicles to bring that to Aaron, and there's a desk right outside the door, in fact, that you can bring. Anyway, so
yeah, and I'd agree.
We're really anxious in
Thank you. And yeah, it's the same thing I'd say with, the IETF. Usually I count on the IETF, and some IETF person will say, well, participate in the process. And yes, I encourage that. And with the RIRs, they are member run or, member service, and in the same way that I can't get something fixed as a vendor until I have people saying, I will spend money or I won't spend money. Yeah, we all have to sort of be vocal in our concerns. Thank you. All right, I think we're a little bit over, but thank you very much. And if you want, catch me for more questions. I'm here all week.